So let's say you want to find the slope of a secant line for the following values of x. So you're given an x and a formula and a point, like 1, in this formula here, and you're trying to find the slope of the secant line. Now the first thing that you should remember is that in order to find the slope, there's an equation y2 minus y1 over x2 minus x1 is equal to the slope. So in this case, we're already given the point P10, and the point you're given first is always going to be the x1 and the y1. So in this equation, we can already plug in 0 minus over 1 minus. And then here, if we solve for the first set of a, we're given our x already, 2, so we can plug in the second x over here. And all that's left to find is y2. In order to find y2, we're going to use this formula. So we're going to plug x in. We're going to find sine 14 pi over 2. Now, to find this sine 14 pi over 2, we have to break it apart. So the first thing I do is just divide 14 and 2, so I can get sine of 7 pi. And then what I do is I break down the sine 7 pi by subtracting it by 6 pi, so we can isolate the pi. So sine of 7 pi minus 6 pi would equal sine of pi. And if we know what sine of pi is, sine of pi is equal to 0. So now we figured out our y. And so we're left with 0 divided by 1, which is equal to 0, and your answer is 0. Now repeat this process with all the numbers, assuming that you understand trigonometric evaluations and other forms of trigonometry. It's a prerequisite for calculus. But if you don't, I would recommend using a math calculator, AI, or any tool where you can import this equation and learn more about the trigonometric identities. So I'm going to quickly enter in the solutions. And so as you see below here, there's a question that asks, do the slopes appear to be approaching the limit? And if you look at the overall numbers, there's a lot of inconsistency. As you see, while the value of y2 as well as x go down, while the value of x goes down, y2 is sometimes going down and then going up and then going up again and then down. So it has a really oscillating pattern to it. So as x approaches 1, the slope doesn't really appear to be approaching any value. So because it's not approaching any value, if you were to plug this equation into Desmos, or graph it, what you would notice is that oscillations would form. And these oscillations would cause us to not be able to actually find an accurate estimation. So in order to find an accurate estimation, we're going to be needing to take x values that are closer to the value of 1. Because, as you see here, we didn't take any x values close to 1. The closest one we did was 0.9, which is not adequate enough. And same with 1.1, it's not adequate enough. You need stuff super close, like 1.001. So, by choosing the appropriate secant lines, we can estimate the slope of the tangent line to be around -4 44.0, and that is if you used one of these values, 1.001 or 0.999. One of these two values, you would get -4.